Slope of lines. Slope of lines. So whenever we are reading lines, we're always reading them from left to right, just like a book, top to bottom. And whenever we're looking at this line, this orange one, given a graph, we can see this is a negative line. The slope is negative because it's starting from the left, going to the right, it's sloping downward. That means it's decreasing in its y values as x is increasing, making it a negative line. You can see that we can still use rise and run. And on the distance formula in the previous section, that's what we did. We used rise and run, the change in x and the change in y. Those acted as the legs of a right triangle, so we could find the hypotenuse, or the distance that's a straight line between 2 points. So we can also use the slope formula. Slope formula should be something that's kind of familiar at this point. But I'm going to go through 2 examples of just showing each way that you can think about it, and it's all going to do the same exact thing. So here are some examples. You can see that this first one, I'm just going to mark it number 1. You can see that number 1 is a positive sloped line. Now, that anytime that we want to use the slope formula, which is y2 minus y1 over x2 minus x1, that's basically saying, well, how much is y changing by and how much is x changing by given 2 points. So you can see there's several points on here. I'm going to choose this one and this one. Why not? So counting rise and run, we know that we're going to end up going up because this is a positive line. So that means the y values are increasing, giving us a positive value. So 1, 2, 3, 4, 5. Went up 5, so I'm going to put plus 5. So rise already is positive 5. Let's see how far over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 10. So that was to the right 10, so that's a positive 10. That coincides with what we said originally as this being a positively sloped line. 5 over 10 is positive 1/2. And you can see, again, that whenever I use a different color, that we can use the ratio, an equivalent ratio of 5/10 as 1/2 to do up 1 over 2. So watch this, up 1 over 2. And that's going to find a slope of a line every single time. Now, let's say you don't have a graph and you need to find the slope of the line. Well, I chose this point right here and this point right here. So that's at negative 1, 2, 3, 4, 5, 6. So negative 6. Down 1, 2, 3. Negative 3. Okay, so let's call that point A. And then the other point at the very end, 1, 2, 3, 4. So point B was 4, and I went up 2. So just like everything else, I'm going to go through, I'm going to label x1, y1, x2, y2. And you're going to say, this looks awful similar to the distance formula and how we were finding the change in x and the change in y. And you're correct. It is extremely similar in that's how we're finding the change in x and the change in y. The only difference is with a slope is that we're writing it as a ratio of rise over run, change in y divided by the change in x. So if we wanted to do this, we got to start with our y values. 2 minus negative 3 over 4 minus negative 6. What we should end up seeing is negative 5 over negative 10 or positive 5 over positive 10. Either way, it's still going to be a rise of 5 and a run of positive 10. So I'm going to slash and dash these, boop, boop. So that's positive 5 slash and dash 10. Cool, which if we simplify goes to a slope of 1/2. So you can see how this is repeating itself over and over. Depends on how you want to approach it. Let's go ahead and take a look at the other one over here. You can see that this is a negative slope because as I look at this line from left to right, it's sloping downward, meaning that as the x values increase, the y values are decreasing. I'm still going to choose the 2 endpoints that are plotted. Let's go ahead and just write those down real quick. Point A would be negative 1, 2, 3, 4, negative 4, positive 3, and point B would be 1, 2, 3, 4, 1, 2, 3. So positive 4, negative 3. Cool. So I'm just going to go ahead and label those before I forget. 1, y1, x2, y2. Okay, so let's reverse the process and let's use the slope formula first, and then we can go onto the graph and see how it connects. So y2, which is negative 3 minus 3, and then x2, 4 minus negative 4. Okay, so I'm going to slash and dash this, negative 6, and then slash and dash positive 8. Now, if we simplified that, we know that 2 goes into both 6 and 8, so that would be negative 3 over 4. So that means, cool, it's exactly what we expected. We said it was a negative line, and our rise is actually a drop 3 and then right 4, down 3, right 4. So that coincides with what we saw as the line before we even started. That's awesome. So let's go ahead and take a look at rise and run as a visual on the graph. So we know that it's going to go down, because if we go up from this top point, because we're moving from left to right, then it won't get to the other point. So we got to go down 1, 2, 3, 4, 5, 6. Down 6, cool. That's exactly what we figured. And then over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So minus 6 plus 8. That's exactly what we found, the change in y and the change in x. It was right here, negative 6 over 8. Now, whenever we simplify it, we can replicate that process all over again using another similar right triangle. So I'm going to go down 3 over 4. Down 1, 2, 3 over 1, 2, 3, 4. And you can see it still gets me to the other point. And I can continue that process. 1, 2, 3 over 1, 2, 3, 4. And I can plot the next point.